my name is Avani Kumar. I'm a College of Science ambassador, and I'm representing the College of Chemistry and Biochemistry. I started college as a chemistry major because I loved chemistry in high school and I knew that was what I wanted to study in college. I ended up switching to the biochemistry major, which is what I am now, because it aligns better with what I want to do in the future. I would like to go to medical school and become a doctor someday. I have always wanted to be a doctor, but it's become more apparent to me that that is what I want to do in my years studying in college. I'm a junior, so I just started studying for the MCAT and looking at where I want to apply to medical school. I've been granted so many amazing opportunities at the University of Arizona, and I wanted to share some of them with you all today. I have been fortunate enough to be involved in undergraduate research. There are numerous undergraduate research opportunities here at the University of Arizona. I was actually working in an undergraduate research lab within 3 weeks of moving to the University of Arizona. I moved here from Columbus, Ohio, so I didn't have any connections here prior to my first day of freshman year. I made the connections and I work in the same undergraduate research lab now that I did 2 years ago. And I enjoy every day of it, and today I want to show you guys what I do up close and personal in the research lab today, and I'm super excited to be able to share again these amazing opportunities that I've been granted with you all today. Thank you. Hi, I work as an undergraduate research assistant in Life Sciences South, which is where we are now. I work in the Charray lab. The Charray lab studies cancer research and kind of at the cellular level. It's based on cell migration and studying basically what affects the cellular pathways that impact cell migration. So if you think about cell migration, it would be what contributes to cell metastasis in cancer. So the cancer spreading throughout your body, which is very important, and what ends up being what kills a lot of people in cancer. So what we do in the research lab is very important.
So today in cell culture, I will be freezing down cells for stock. So the cells that we have in culture right now will be frozen down in liquid nitrogen to be stored for future use and for stock cells so that we don't have to keep them in culture. So the first step of what I'm doing is pulling the media off the petri dish that the cells are kept in. So I've just taken the petri dishes out of the incubator and I just pulled off all of the media that they basically grow in. So the only thing that remains left on the petri dish is the cells. So now that it's only the cells, I will put trypsin on the petri dish. I rinse it down the side, as you'll be able to see. The trypsin will basically peel the cells off of the plate so that they won't be stuck on it anymore, so that I can move them. To get the trypsin to work, I will place the petri dishes with just the trypsin and the cells into the incubator for approximately 3 to 4 minutes. Once they're done trypsinizing, I'll be able to see the cells moving on the plate and know they're ready to go. So once I'm able to see that in 3 to 4 minutes, I'll take the petri dishes out, put them back under the hood, and I will put media onto each of the dishes. So the media will stop the trypsin from working. You can over-trypsinize cells, so this time frame is extremely important. The media will stop the trypsin from acting on the cells. So once the media is added on the plate, I will go ahead and pull up the trypsin, media, and cells into the pipette and put them into this 50 milliliter centrifuge tube. So it is very hard to see obviously in the video, but I can see the cells right now, so I'm rinsing them all down the plate and placing them in the centrifuge tube, making sure I get as many cells as possible. So once the cells are in the centrifuge tubes, they are obviously spun down to basically separate the cells from the trypsin and media that they're in right now. So I'll go ahead and turn on the centrifuge for 3 or 4 minutes again. And as you can see, there's a pellet. It's very hard to see, like I said, but there's a pellet of cells in the bottom of the centrifuge tube. So now I will pour off all of the media and trypsin that's on top, but leave the pellet of cells in the centrifuge tube. I'll then take a pipette and approximately 3.8 milliliters of media again, and I will resuspend the cells in the centrifuge tube. Resuspending is very important. I want to evenly mix the cells throughout the media that I'm placing inside the centrifuge tube. It's very important that they're evenly spread about so that when I separate them into separate cryovials to put in the liquid nitrogen, the cells are evenly distributed throughout the media. So I basically just pulled it up and down through the pipette. Now I'm going to add some DMSO. DMSO is just the agent that is used to keep the cells good, basically when they're frozen down. And I go ahead and we'll mix that in as well. Now that the cells are ready to be placed into cryovials, I'll pull up 1 milliliter of the cell solution, which is just media, DMSO, and the cells, and I'll place 1 milliliter into each cryovial. I have prepared about 4 milliliters of the solution, so I will place it into 4 cryovials. The media is simply, we add FBS and antibiotic. FBS is basically the food for the cells, and the antibiotic prevents contamination. So once I place the cells in the cryovials, they'll be ready to be frozen down. It's very important. We obviously work in a sterile field with under the chemical hood, so the cells are kept sterile. Everything under the hood is sterile. It's been sprayed thoroughly and wiped with ethanol before it's brought under the hood. I've already labeled all of the cryovials with the passage number, the cell type, initials, and dated. These are lung cancer cells. All the graduate students in my lab work with different lines of cancer. I work with lung cancer with my graduate student. These cells are placed in the -80 freezer for now and will be placed in the liquid nitrogen after 24 hours of being in the -80.
Predominantly what I do in lab is what you saw today. I work in cell culture where I prepare cells and the cells that we have in culture for experiments that my graduate student does. I do participate in a lot of the experiments myself. It's just under what she wants to do and what she's researching at the time. This semester, in the spring of my junior year, I will be starting my senior thesis. My senior thesis is a project that I get to do myself based on all the techniques and experiments that I've done with my graduate student, with the graduate student that I work under. I will be able to work on kind of my own idea for the next year and a half. So I'm super excited for that. I've had such an amazing experience doing research, and I really hope that if you're interested in research, you put yourself out there and get involved because it was one of the best decisions I've ever made. Thank you.